In this section, we will discuss Python generators. Python generators provide a memory efficient way to generate sequence of values on the fly. They enable lazy evaluation, which means values are calculated only when needed, and they preserve the state between iterations. Let's look at what makes the generator so useful. They are incredibly memory efficient for working with sequences. They use lazy evaluation, calculating values only when needed. They maintain the function state between the iterations, and they handle large or even infinite sequence elegantly. Now let's examine a simple generator function to understand the basics. Here we have a function called fun that takes a maximum value as its parameter. Inside the function, we initialize a counter to 1. Then we create a while loop that continues until the counter reaches the maximum value. The magic happens when this yield statement, instead of returning a value and terminating, the function pauses execution and yields the current count value. After yielding, the counter increments by 1. And when we create our generator by calling fun of 5, it doesn't execute the function body yet. It just returns the generator object. The real execution happens when we iterate through the generator using a for loop. Each time through the loop, the generator resumes where it left off, yield the next value, and then pauses again until the next iteration. Let's compare the yield with familiar return statement to highlight its differences. In generator example, we have a function that yields 3 separate values 1, 2 and 3. When called, this function does not return all values at once. Instead, it yields one value at a time, pausing between each yield. The difference is fundamental. Generator produces values incrementally, while the regular functions produce the entire results immediately. The generator expression offers a more concise way to create generators using a syntax similar to list comprehensions. Here we create a generator that produces square numbers from 1 to 5. Notice the syntax. It looks like the list comprehension but uses a parenthesis instead of square brackets. When we iterate through this generator, each value is calculated on demand, giving us 1, 4, 9, 16 and 25. Generator expressions are perfect for simple transformation that do not require full syntax of a generator function. Now let's dive into some deeper insights about generators. They are Python's elegant solution for memory efficient iteration. They represent a powerful programming concept with several key advantages. They generate values on fly, calculating each item only when it is needed. They can pause and resume function execution, maintaining their complete state between the calls. They preserve all local variables and execution position between iterations, and they optimize the memory usage by avoiding the need to store entire sequence in memory. Generators are particularly valuable in several common scenarios. They excel at processing large datasets that might not fit in memory. They can create infinite sequences without running out of memory. They enable lazy evaluation of sequences, computing values only when necessary, and they support memory efficient computation for data processing pipelines.